A long way from September to December. When I checked homework into September, most people looked at me like I was bananas. You're going to check this stuff? Now, I put up 2 questions on the board. I can't even barely stop them from talking about the math. See, I'm not getting too mad about it because everybody's sort of into it. Yesterday was one of our best days. People were into it. They're like, hey, I'm going to check this out. I couldn't get the answers up fast enough. It was beautiful. We can get through this. We should get some shirts that say, I dig Trig. That's how good it's going. Who wants to tell me what to write for the first one?
C squared equals 12 squared plus 18.
Okay, I'm going to write the formula, not because you have to. I do not force you to write the formula. I don't. So if you didn't write the formula, no problem. If you went right to here, say it again.
12 squared plus 18 squared.
12 squared plus 18 squared. Then you take a deep breath because now the rest is a different kind of calculation. You're not looking at the triangle anymore. You're not trying to figure out which one goes where anymore. You're just doing what it says to do. 12 squared, there are 2 ways to do that in your calculator. If you know where the squared button is, and the calculators you borrow here have a beautiful squared button. You just hit 12, you find the squared button, and then boom, squared. 144, good. The other way you can do it is just hit 18 times 18. That works too. Doesn't take all that much longer. 324. Yeah? Then you just add those together. What did you get? 468. Now, if you were away yesterday, maybe you don't know about this last step. If you've seen them before, you're not surprised by this.
Square root.
How do we, square root undoes squaring. 21.63. So we'll just take the 21.6. How'd you do? Did you write what it was, though? Is it wagons?
Centimeters.
Centimeters, right? And for those of you who are considering work in the trades, this is really important. You don't walk into Home Depot and go, yeah, I'll have 21.6 wood, please. They're like 20, what? Better give me more than that. Centimeters? Because maybe you want that. You know, a dowel or something like that. No, I need 21.6 feet. You know? No, I need 21.6 yards. It really matters that you know which one you're talking about. Yeah, you're right. Like as a final answer, would we really go 21.6? And the answer is maybe. So we'll usually go 1 decimal place. Will you? Yeah, let's go 1 decimal place for now so we know how to do it. Okay? How is this one different? For anyone who thinks this one's the exact same question, how is this one different in preparation for maybe writing the quiz today, if people are writing the quiz today? You can write the Pythagorean theorem quiz whenever you want. I told you it was going to be out of 20 marks, so that's worthwhile. It's going to have 2 like this and 1 easy word problem. Not a crazy one like some of the crazy ones in the homework. Just a nice little word problem. What's different? He likes the formula. Shh. He prefers the formula. He goes, no, I'm going to do this. I can see right away that I'm doing a leg or another side. I'm not doing the hypotenuse. It's got to be smaller. I heard some people over here talking about that going, if you're going after a smaller side, you got to subtract. So you don't have to write the formula. You could just go, oh, I'm going after x. So I've got to go subtract because the hypotenuse has got to stay the longest. I can see in the picture, hypotenuse has got to be the long one. After that, usually relaxation sets in because your calculator takes care of both of those for you, even if they're crazy decimals or whatever else. 153, and the final step is to square root that crazy thing. 12.36, so we'll go with 12.4 for tenths. How'd you do? Okay, but final test, 12.4 camels?
Centimeters.
Meters. Okay, so take a look. And just imagine yourself going to Lowe's to order the wood you need. You better know which one you need. It's a big difference getting 21.6 centimeters of wood and 12.4 meters of wood. Yeah, that's about the biggest mistake you can make. Yeah? All right. There's going to be a little delay in the video here while I hand out today's sheets. We're going to do the lesson first, and then I'm going to write the quiz on the board. Yeah, it's not just quiz day. The quiz should take, I don't know, if you're good at this, how long do one of these questions take?
Are we getting a test back?
No. I was at a Christmas concert last night, and so no marking occurred.
I'm really happy to say that I fully understand it.
It's good, right? Today, a little more difficult. Not bad, a little more difficult today.
I have 2 questions.
Okay?
One, it doesn't matter if I did a squared plus b squared.
No, and I think I know why you're doing it that way, and that is cool. I like that. So you can do it the other way around. Did I give you this sheet? Yeah. I gave you this. I didn't give you one? What happened?
I have another question.
Okay, go again.
If more than one, if you call more than one goose geese, you call more than one goose geese.
Yes. No, no, you don't. Yeah. Goose, geese, moose, meese. Okay, here we go. Now's the time. During my warm-up examples, if you still had your headphones in. Well, okay. I don't like it. Now's the time. Phones away. Headphones out. Don't just slip them behind your hair. Headphones out. Here's our learning goals today. To learn what the 3 primary trig ratios are. You're like, what are you talking about? Yeah, I know. That's our goal today. What are the 3 primary trig ratios? You might have heard the words before. And you'll be successful if you can explain what they are, what the trig ratios are, and I can write the ratios for any right triangle. Whoa, that's heavy. That sounds heavy, but here's my explanation. In trigonometry, the sides of the right triangles are labeled according to the desired acute angle. Shh. Most important moment. Let me help you with this moment. This is perfect in this class. All right? I want to ask you a question. I want you to really think about it. So it's clear. I'm going to go over and stand by these chalkboards. Which side of the classroom are these chalkboards on?
Left. Actually, right.
Hang on.
I say right.
Yeah, I heard the perfect answer in there. And Adam's answer was perfect too. He said left. No, wait, it's right. It's left to you, isn't it? It's on your left, but it's on my right. To Chris, it's behind him.
Depends where you are.
Depends where you are. Big moment. That's what this is saying. When labeling right angle triangles, it depends on what angle you're going to use. So, this one said, if the desired angles be, please, look at, I'm actually on my knees. If you're watching the video, I'm literally on one knee, begging you. Circle the angle you're going to use. Yeah? It says use angle B. I'm like, okay, I'm using angle B. I just circle it. If that's the angle you're going to use, this is the hypotenuse, just like it was yesterday. Hypotenuse hasn't changed at all. Then the one beside B, adjacent to B, is right there. It's attached to B. Sometimes people say it's attached to B. It's right there beside B. And then this one over here is the one that's opposite to B. That may seem easy, but that'll be the difficulty you have. So circle the angle, please. Please circle the angle you're going to use on your picture so you know which side's going to be the opposite or adjacent. Otherwise, you'll be doing what we're doing in the classroom going, is the chalkboard on the right? Is it on the left? Is it behind? Is it forward? No, decide where you're going to look at it from. And once you decide, you're good. Now, something else little has happened here. When we're labeling triangles, notice that big A is the angle, and then little a is the side across from it. This is a labeling trick by math people to go, let's all do it the same. Always label sides opposite each other. So big C, big B, little b, always across. And the capitals are always angles. Okay, so let's just write this, but very briefly. Your English teacher's not going to like what I write here. Just the reference you need. Capital letters are for angles. Small letters are for sides. Is that a universe rule? No, that's just something we agreed on. The human race agreed on thousands of years ago. Say, let's just all do big letters angles, little letters sides. That's key in all this. You're going to ask me that question before we get too far, other times. But that is the key to labeling triangles consistently. So we do it consistently. By the way, you have to put those labels on there, right? You have to write hypotenuse on your diagram. You have to write adjacent and try and spell adjacent, A-D-J-A-C-E-N-T, and then opposite. Okay, your next picture changes the game. Tries to mess you up a little bit. Do you need more time here? If the desired angle's A, get ready for this. I'm going to circle A on there. This is still hypotenuse. That still stays there. You can still label that hypotenuse. Hypotenuse is still the largest side. It's still across from the right angle. But now this one's the opposite. So label your diagram opposite down there. And now this one's the adjacent. Stare at that for a minute until you can see the association with my silly example going, where's the chalkboard in the classroom? Is it left? Is it right? Is it back? Is it front? It depends on where you're looking from. And if you look from A, the names opposite and adjacent reverse. That's going to mess you up. So you got to watch out for that every time. And what's Mr. Todd's advice? Circle the angle. And I'm not talking to you because you're in grade 10s. Or you're in grade 10. I say it to my 11s, say it to my 12s, say it to my kids in university. Circle the angle you're using. Yeah? You might have a choice. You can choose. Just circle the one you're going to use. Jackson.
Now, what if the desired angle is C?
You won't use C because C is the 90-degree angle. You'll use one of the other two. It's a very good question. But we won't be using the 90. We'll be using one of the other two angles. Okay? Those are the angles that are define what the triangle looks like. 90 doesn't really decide what it looks like. The other angles decide what this thing looks like. For instance, if you go to the height of a tree, the 90 is always going to be 90, but on different trees, the other angles are going to change, so those are the ones we use. Okay? Good question. Great question. Okay, do you need more time? What you really need is practice on these. That's what you really need. So we got to work our way through. So, does this look as the same as yours? This is your next. Oh, you already had this part, right? We're now looking here on your note. Below that blue line is where we're looking. Here's something new. And at first, you're going to be like, what are you talking about? And then I'll give you a memory tool. Okay? The sine, this is pronounced sine, is equal to opposite over hypotenuse. Have you seen this before, S-I-N? Not sin like sin, Catholic. No. Yeah, this is sine. It's on your calculator. Have you heard someone talk about sine, cosine, tan before? Here it is, finally, sine, cosine, tan. And yeah, you walk to any math classroom, and there's a very good chance you'll see sine, cosine, tan. Like you look around here, sine, cos. You'll see that on the boards all the time. Here it is. I'm introducing it to you. So, sine is the opposite side divided by the hypotenuse. Why do you care? Well, you don't care yet. It's going to take 2 lessons before you go, oh, I see what you can do with this. Yeah? So it's a 2-part lesson, today and tomorrow. So, cosine is adjacent divided by hypotenuse. And tan is opposite divided by adjacent. Good. So in my picture with angle A, here it is, I'm going to circle angle A. What's the label of the side that's opposite to angle A? Little a. I'm telling you, brace yourself. This is going to do some amazing stuff. But we got to lay the groundwork first, and let me seem a little weird. What's the name of the side that's the hypotenuse in the triangle? Little c. How about cosine, though? Cosine says do adjacent over hypotenuse. What's adjacent in my picture? What's the label? Little b. And what's the hypotenuse in the picture? Still c. Yes? It's okay if this seems a little weird. That is totally fine. It's going to take a while for me to get it all laid out for you so you can see what's going on.
Wait, I'm really too sure.
Yeah, it's out there, man. Yeah. How about tan? Tan is opposite over adjacent. Opposite is called A in the picture, and adjacent is called B. Now, I must tell you, I really believe I have to teach that way. But many of you will find it much easier once there's actual numbers here.
Can I say hi to your microphone?
Yeah, who would you like to talk to?
Can I talk to you and listen to you?
You've been doing it the whole time. If you go back and watch the old videos, well, except when you were sleeping, we go back and watch old videos. All our conversations are there. If that bothers you, I'll have to take them down, right? Because they're on YouTube right now. Don't get too upset here yet. Let me carry on and show you what we can do with this one. So, you should be right now thinking, how am I ever going to remember all that? Watch this. Watch this. This is what everybody over grade 10 knows. Good chance if you go home and talk to a family member or a cousin or whatever, and you say what I'm going to say in a minute out loud, they'll know what you're talking about. Okay. Sine is, can you write it like me? A very large letter O. And then as small as you can write, finish off the word opposite. Yes? Then the next word is hypotenuse, a very large letter H, and then as small as you can write the word hypotenuse. And we're up to something here. We're up to a memory tool. I'm telling you, you go to any grade 10 or more class, they'll know this memory tool. So, sine is opposite over hypotenuse. So. Cosine. Again, do my short form. Giant letter A, as big as you can write, and then as small as you can write the rest of the word adjacent. A-D-J-A-C-E-N-T. Cosine is adjacent over hypotenuse. Again, draw the H as big as you can and the rest of the letters as small as you can. What are the first letters here? Cosine is adjacent over hypotenuse. Maybe you've heard this little phrase before. Maybe you heard some random you know say this. So, ka, okay, 10, SOHCAHTOA. He already knows what's coming. Did you hear it before? Did you see what's about to happen? You've heard it before, yeah. 10 is opposite over adjacent. So that's 10 is opposite over adjacent. There it is. Let me say it out loud. And every trig student over grade 10 will nod when you say this. You walk up to somebody who's taken any trig, and you're like, do you know SOHCAHTOA? And they're like, yeah, SOHCAHTOA. It's how you remember these things. So as long as you remember SOHCAHTOA. So I'm going to say SOHCAHTOA.
Do you know SOHCAHTOA?
Do I know? So me and SOHCAHTOA,
Go way back.
the story, we go way back. The stories I could tell about SOHCAHTOA. That week in Bermuda, me and SOHCAHTOA, what a good time we had. We went to the beach, me and SOHCAHTOA, and we got a tan.
I knew where this was going as soon as you looked at the I knew
cosine to your business, and then sec.
I don't know what you're saying. I'm really scared about the videos. Cover it up. Here, write this really big underneath. So, did I make it too big? Ka toa. That's how we'll remember what's going on. Like, Mr. Todd, this is what kills me in math, when I have to remember something. You need this. Somewhere between now and next Thursday's test, you got to be able to go soka toa and spell it. And then after that, you won't have to remember because it's all right there. I'm going to use it like 1,000 times in the next couple of days. Who's heard that word soka toa before somewhere else? Yeah? Yeah, you've heard someone say it. It's hard to avoid it. Yeah? Question?
I learned no.
No, you're just saying, I heard it. Soka toa, soka toa, soka toa, soka toa, soka toa, soka toa. Maybe we could do it to a Christmas song.
Jingle bells.
Soka toa, soka toa, soka toa, toa. I don't know. I did that to my own kids last night. You know, 7 to 10-year-olds get crazy at Christmas time? So I was like, don't. I kept saying it over, and I just started singing. Don't. Don't. I was there last night. I was looking for you. I had my peepers going like this.
Where were you?
I was on the left side looking in, about 11 rows back. I thought maybe you were ahead of me. For a second, I was like, I think it's her, but it was dark and I couldn't really see.
I was on like the right side. Like there's two sides. I was on like this side.
You're on the opposite side or you're on the adjacent side?
Wait, well, if the stage is here, there's like, I was over here.
If the stage is up there, I was over here.
I was over there.
Yeah, I think it was you. Were you sitting there towards the middle though? Oh, then it wasn't you. Yeah.
I didn't see you though. I literally waited.
Oh, I was looking. Did you write down in big letters Soka Toa? I need to tell you, it's actually much easier than that to do it with numbers. Are you ready? Here we go. We're going to do it with numbers. State the primary trig ratios. What are the primary? Soka Toa. That's what they're talking about. Do Soka Toa for angle theta. Once you know what angle they want, what should you do? No. Sir, who is it? Shamar saved us. Circle what angle you're going to use, because that changes what the sides are. This is still hypotenuse. And yes, most mathematicians don't write out hypotenuse every time. They write hype. Yeah. Opposites. See, circling it mattered. Now this one's op. Yes, most mathematicians write op. They don't write the whole word opposite every time. And then we don't have to spell adjacent. We can just write a. Ooh. Come on. Adjacent. Now sine is opposite of hypotenuse. If you memorize Soka Toa, what's the opposite side? How much is the opposite side? How much is the hypotenuse? 5. So after all that lesson, all you got to do is go opposite of hypotenuse. It's just going to be a ratio. That's all. So it's not nearly as bad as I made it out to be. How about cosine? And I've labeled it here. I said adjacent to hypotenuse. How are you going to know? So, ka, toa, ka, C-A-H. What's the adjacent side? 4. What's the hypotenuse? That's as easy as they'll be today. Circle the angle and do so ka toa. Is it going to get harder tomorrow? Yes. Part 2. We got to do more. But part 1, this is pretty much it. Just memorize Soka Toa. You just walk around singing your Christmas songs, saying Soka Toa all the time. Everybody else is deck the halls with boughs of holly. You're Soka Toa, Soka Toa, Soka Toa, Soka Toa. What's the opposite side again? 3. And the adjacent? 4. Now, you're like, why do I care? Brace yourself. By the end of tomorrow, you're like, oh, that's why I care. Yeah? So it takes a little while. For now, I'm just setting it up, getting everything put in position. Then you're going to be like, oh, got it. How many more do I got to do here? Lots more to go. Good? Next slide. Given triangle ABC. Okay. Triangle ABC. Here we go. Triangle in festive green here. Got it? You draw a right angle triangle like me. It says angle B is the 90. So I'll draw it on here with a capital B. If that's capital B, what's little side b? What are we going to call little side b? The one straight across. So this is little b. This upsets people who have memorized the Pythagorean theorem, by the way. Like, you can't do that. It's supposed to be C. I'm like, all right. I know. I know. You got to get a little more used to it than that. Then it says A is 6. So I'm going to make this one A. And B and C is 8. I know you're upset. I know some of you are angry. You're mortified. You're like, you can't make C the side. I'm like, well, you can actually, and you got to get used to that. Let's go. It does change it in this question. They wanted B to be 90, so I got to go B over here, and that's very upsetting. And I'm with you. But the Pythagorean theorem was about a pattern. Hypotenuse squared equals A squared plus B squared. It wasn't necessarily about those specific letters. So we've got to grow a little bit and go, okay, it's okay, I'll be okay. I know I got to add to get a hypotenuse. I got to subtract to get other sides. I'll be okay. It'll be all right. This says find tan of A. Now hold on, there's lots to talk about here. First of all, what is tan? Don't look back. See if you've already got it memorized. So, ka, opposite over adjacent, because we want oa. Toa, opposite over adjacent. That's a major breakthrough. Got to have that in your head. Toa. Do you see the toa? Here, I'll get out my highlighter. Toa. Not do you see my toa? I didn't want red. I wanted yellow. Yellow. Highlighter. Bigger. Highlighter. Toe. Ah. Do you see the toa? T-O-A. Now, they want me to use angle A. I don't even see an angle A in the picture. Which one's angle A? It does matter. That's little a. So where's big A? Down here. That's how we do it in math class. The A's are across from each other, the B's are across from each other, the C's are across from each other. So, we're using angle A. Now that we know we're using angle B, A, what should we do? Circle the angle you're going to use. I'm telling you, that's vital. You're like, oh, I don't need to circle it. I get it. I'm like, everybody circles it. The grade 11s, the grade 12s, they circle the angle they're going to use. Jackson.
Are we using angle A because it says tan A?
Oh, great question. He says, are we using angle A because it says tan A? Yes. That's our only hint in the whole question that tells us we got to use angle A in this question because it said tan of A. If it had said tan of B, we would have done something different. Or tan of C, we would have done something different. Now I'm ready. If that's angle A, which side's the hypotenuse? B is the hypotenuse. Very upsetting. You can be angry. You can glare at me. You can be like, why are you messing this up? C is the hypotenuse. I'm like, I know when you first learn it's supposed to be C. I get it. If that's angle A, which one of these is opposite? Which one's adjacent? This is adjacent, so I'm going to put ADJ down there. I'm going to put OPP up here for opposite. If you get those labels on, you can call Pizza Hut and order your dinner because you're about to be done the question. Things are good once you got those labels on there. That's going to be the hard part, is labeling those. Because TOA says opposite over adjacent. How long is opposite? Opposite is 6. Adjacent is 8. I'll be very happy to see that answer, but we could do a little better. 3 over 4. We could reduce it, okay? I'm not going to get sidetracked by reducing this chapter. Yes, I'll mention it, but I'm not going to get sidetracked by this chapter. It's not the most important thing anymore. What? Telephone ringing? Someone's what? Oh, someone actually calling Pizza Hut? Are they doing it by accident? Someone's phone. We can hear someone's phone. Okay? These are not, I'm not saying these are easy. There's lots to know here. But in the end, the answer comes out pretty simple. What are we going to do with it? That's not clear. But another piece of the puzzle is about to come right now. Do you do a lot of puzzles at home? We love puzzles at our house. If trigonometry is a puzzle, we've now got the outside done. You know the outside of a puzzle when you go, okay, I got the outside. Got the edgies done. That's what we call them in our house. We got the edgies done. Now let's get a little bit more of the picture. We can use our calculator to get these answers. Determine sine 32. There's some little rules though. Does everyone have a calculator? You need a calculator for this. Let's take a second and make sure everyone has a calculator. Not your phone. Your phone is out. You're like, oh, but I like my phone. I've been using my phone. Yeah, your phone is going to stink at this. I don't say that because I'm a nerd. I say that because I know your phones, and they stink at Sakatoa. It will actually, if you turn off your lock and turn it sideways, it appears. But I'm telling you, it's hard to work with. Most phones are painful to use sine, cos, and tan. Does everybody have a calculator now? I'm going to bring a calculator up on my screen too, okay? So you can see. Calculator. And if my calculator doesn't look the same as yours, that doesn't really matter. Is it going to come up on the screen? Is it going to work, or is it going to explode everything? It's working! Now look, friends. The calculator has to be in degree mode. Look at the top of your calculator. Mine says DEG. I think most of yours only says D. Does yours say D, or does it say something else?
It says DRG.
What's that?
The R and G isn't like the D, but it says DRG.
Oh, just the D is highlighted though.
Yeah.
Yeah. If yours doesn't say D, call me over and we got to fix it. It's got to be in degree mode. Right at the top, there should be a little D highlighted. R. So here's how you do it. You go to Shift, Setup, and then you hit 3 for degree. Now it says degree up there.
I'm too young for this.
Shift, and then you hit Setup, and then you hit 3 for degrees. And then you'll switch over to degree mode. If you're having trouble, call me over. And if you're having trouble in a test, call me over. I'll come over and fix your calculator, but we need to watch to make sure it's in degree mode.
Yeah, you gotta please.
Let me see. You hit Shift Mode. Shift Mode. Oh, hang on. Shift Mode. Okay, hang on. Shift, and then the Mode button. And then hit the number 3. And now it should say D at the top.
Hey, I got that answer.
Now hit sine 32. And you'll know you're not in degree mode if you don't get the answer of 0.529919264. Do we need all the decimal places? No, no. I only put them up there so we all can agree we got it on our calculator.
I have a question about, like I did it with some degree mode. What did it do differently to get that answer?
What did the other answer mean?
Yeah, like what did it do? Like,
Yeah. It's like it's working in centimeters instead of inches or something. Like it's working in a different measurement system, so it's giving a different answer. That's all that's happening. So we got to be in degree mode, which seems weird. You say, is there other things than degrees? And the answer is yes. So, oh yeah, good stuff. That is way advanced stuff. We don't need that yet. So if you just clear and then go sine 32 equals 52991292642. All we're confirming is you're in the right mode. All right? Did I what? So, the second part of your homework, check this out, is just making sure you can type them in and get the right answers. But we'll do them together. We'll do these ones together. Try the following. Right now, try cos 32, cos 60, sine 35, and tan 38. I'll do them slowly. Let's just make sure, before we release into these tougher questions tomorrow, that we can get our calculator to get these answers. I'll do them slowly. Try typing them in. Cos 32. And it says just do 4 decimal places. Why 4 decimal places, Mr. Todd? I know, it's not clear why I'm saying these things.
What if you can't?
What do you mean?
What if the question is
Oh, if they doesn't give you 4 decimal places, then you just write down what you do have. Because I think the second one's 0.5, isn't it? I get what you're saying now. Sine 35. You try them out, then look at my answers. Sine. Not allowed to say sin at this school. Check to see if you got the same as me as you do each one. Is this the end of the lesson? How'd it go, friends? What about the rounding? How'd the rounding go? There's some questions about rounding last chapter. Can you see why this is 0.7813, not 2? How do you decide? The next digit decides. So if it's 5 or more, you go up. If it's less than 5, you go down. All right? Any questions there? Bad news. If you can't do tonight's homework, tomorrow's is going to seem really mysterious. You really got to take a shot at tonight's. You really got to take a shot at it. What did I say something funny? Is it all right? Take a run at tonight's homework so you can do tomorrow's. I have no idea what just happened.